Okay, so I'm sure you've read the problem over. They're looking for a maze that, on average, takes a rat 1 minute to complete. Okay, so we look at our data here, and so let's think about the data. Independence. Now, in this case, independence looks like it probably is fairly reasonable, and that is the time that it takes one rat to complete the maze is probably independent of another rat's time to complete the maze. But we'll have to assume that these times are collected randomly. 21 trials is less than 10% of all trials. Nearly normal. Okay, now the box plot shows an extreme outlier at 93.8, which should be dropped. An outlier that big should not be included in your inference. Okay, now let's look at the histogram without the outlier. I went in and I deleted 93.8 from the data. Histogram's not terrible. It's not great. It hasn't got two modes. It's, I don't know, but it's only 20 data items. So, but the normal probability plot to the rescue looks very good. Okay, so we will, based on the normal probability plot and the fact that the box plot looks pretty good without that outlier, then we'll say the sample is nearly normal. The preconditions have been met. A t-distribution with 19 degrees of freedom can model the sampling distribution of the average completion time of the sample. So we run one variable stats, and and we can see that y bar is 50.13, and the standard deviation of the sample is 9.9. So the standard deviation of y bar in the sampling distribution will be 9.9 divided by the square root of the sample size, which is 2.214 approximately. So the null hypothesis. The average completion time for a rat to complete the maze is 60 seconds. Mu equals 60. The alternative hypothesis is not that it's greater or less than, although clearly the sample is less than, but simply that it's not equal to 60, because they need a maze that's going to equal 60 seconds. They don't want it to take too long. They don't want it to go too short. Okay? So alternative hypothesis is that it's not equal to. So we're going to use a two-test, two-tailed. So the t-score will equal y minus mu over s divided by the square root of n, which is 50.13 minus 60 divided by 2.214, which gives us a t-score of negative 4.45. Now the p-value is going to be 2 times tcdf minus 99 comma negative 4.45. Hey, honey.
Where's my good girl?
Hold on. Let me turn. I'm doing a recording here.
See, when Bibi's not here, then you don't have to get up.
Okay, my wife just came home. All right. Okay, so the p-value is 2 times tcdf. Now, that is really small, even for 20 degrees of freedom, or 19. So it's 0.000275 approximately. With a p-value this low, we reject the null. Now, p-values are p-values are p-values. It doesn't matter what your degrees of freedom are. The p-value gets interpreted the same as we've always interpreted it with proportions. With the p-value this low, we reject the null hypothesis. There is evidence that the maze completion time does not equal 1 minute. Now, I'll leave it up to you. You can go ahead and do the confidence interval to find out what that is, what the completion time is. You shouldn't have any trouble finding t-star. I've got a video for how to do that. So that is that.